Tonight, 6 teams of St. Michael's Hospital's all-star scientists battle it out to win funding for the next medical breakthrough. It's the 8th annual Angels Den, and here's our host, Reshmi Nair.
Good evening, I'm Reshmi Nair, and welcome to Angels Den, Canada's biggest medical research competition. We are celebrating 8 years of Angels Den, and we are so happy to be back with a live audience. Welcome, everyone. Tonight, you get to witness the future of medicine as 6 teams of doctors and scientists representing the brightest minds at St. Michael's Hospital compete to fund their revolutionary research. Now, after months of hard work, it all comes down to this: 6 astounding projects, 3 judges, our jury members, and $500,000 in funding to bring some cutting-edge medical research to life. Every year, Angels Den comes back bolder than ever because funding groundbreaking medical research has never been more essential. There is still so much work to be done, and who better to speak about the importance of medical research than the President and CEO of St. Michael's Hospital, Dr. Tim Rutledge.
From vaccines and antibiotics to antivirals and artificial intelligence, every revolutionary medical discovery gets us closer to addressing the toughest health challenges of our time. And what each advance has in common is this: research. If the past 3 years have proven anything, it's that medical research matters now more than ever. Angels Den jumpstarts discovery and transforms ideas into breakthroughs that might just change how we heal people and how we deliver care. And it's no wonder Angels Den is coming from St. Michael's Hospital, a research powerhouse that is home to some of the world's most brilliant scientific minds.
Thanks, Dr. Rutledge. Let's get to it. I'd like to introduce this year's Angels Den judges to keep our scientists on their toes and make some high-stakes decisions. First up, she's a neuroscientist and beloved science communicator. They call her Science Sam. It's Dr. Samantha Yamin.
Hello, thank you.
And new to our panel this year, she is the CEO of Visions of Science Network for Learning, an organization making the STEM field more accessible to students in marginalized communities. Please welcome Dr. Eugenia Addy. And our final judge, Jillian Riley, is president and CEO of Tangerine, Canada's leading digital bank. Thank you for being here, Jillian.
Thank you.
Samantha, all of tonight's researchers will be delivering their pitches in plain English. As a science communicator yourself, why is that so important?
Science should be by everyone and for everyone, and that's especially true when it comes to healthcare-related research. At Angels Den, you're getting innovative and creative ideas to solve problems that Canadians and people around the world are facing.
And you are new to Angels Den, Jillian. What's your impression so far?
I must say I'm so inspired to be here tonight. I think it's really an amazing event.
And Dr. Eugenia Addy, it's your first year with us. We are so lucky to have you. How can Angels Den inspire our students and encourage them to explore STEM?
Above all, these researchers, what they're doing, it's really going to show to many, many youth that you can do this too one day.
Thank you, Eugenia. And speaking of inspiration, we are so grateful to our frontline healthcare workers who continue to rise up and face challenges every single day. We can never thank you enough. I would also like to take this opportunity to thank all of our donors and sponsors. Now, our jury and panel of judges aren't the only ones who get to decide how the competition unfolds. After the show, we need all of you watching to make your voice heard and vote for the Canada Life People's Choice Award. This is a big deal. The winning team will earn $100,000 to fund their project. Voting will open at 8 p.m. at angelsden.ca. That's where you can also find out how to make a donation and help fund the inspiring work being done at St. Michael's Hospital. Those who don't win the top prize will earn $25,000 to fund their projects. No one goes home empty-handed. Here's how tonight will work. Each of our 6 teams of St. Michael's finest will have only 4 minutes to pitch their projects. After each pitch, our judges will ask their questions. We have 2 top prizes worth $150,000 each, and our first 3 teams will be competing for the Keenan Award for Medical Discovery. The first 3 teams are working on new medical devices, treatments, and therapies. Our first pair of scientists want to save injured muscles by using bubbles. Before we bring them out, let's get to know Dr. Howard Leong-Poi and Dr. Jane Batt.
Hi, I'm Jane Batt. I'm a respirologist and scientist here at St. Michael's Hospital.
I'm Howard Leong-Poi. I'm a cardiologist at St. Michael's Hospital and also a scientist.
I was born in Portage la Prairie, Manitoba. I really wanted to be an astronaut, and I was going to do that by becoming a fighter pilot first. I wear glasses, and that was not an option back then. I ended up going to medical school. It was the next best way for me to get to the unknown outside of being able to physically go there.
I was born on an island called Trinidad and Tobago. I came to Toronto to go to University of Toronto. My dad wanted me to have the best education possible, and it's become home for me.
Yeah, we've known each other for at least 10 years. Howard's in cardiology, I'm in respirology. We've shared a lot of patients with consults, but from a scientific standpoint, this is the first project that we've really worked on together,
yes.
Right? Our project is a completely novel approach to maintaining muscle that's been injured. Now, if you rip or cut a nerve, all of the muscles downstream become immediately paralyzed. If that nerve takes months to grow to the muscle dies. So now you have a paralyzed hand.
Our research is aiming to use ultrasound to deliver genes to the muscle to preserve them long enough so that when the nerves heal, the
muscle is maintained.
Yes. St. Mike's is super special for me. I get to work with fantastic people like Jane. You know, I've grown deep connections with the patients, and I want to take care of them.
My favorite season by far is winter. I am an avid downhill skier. I get as much time on the hills and the mountains as I can.
If I couldn't be a physician and I wanted to do something and I had the physical ability, I'd be probably an NBA basketball player.
Well, we're taking a horrible situation for an individual and their family, and we're offering them hope.
Giving patients back their mobility with this research, I think, could be fantastic.
Let's welcome Dr. Howard Leong-Poi and Dr. Jane Batt.
Four and a half million people are injured annually in workplace, sporting, and traffic accidents. When the injury is serious, nerves to the arms and legs are cut, disconnecting them from the downstream muscles, and this is catastrophic. Why? Muscles need functional nerves to survive and to function on their own. If you cut a nerve to a muscle, the muscle is immediately paralyzed and it begins to shrink. Now, muscles can regenerate. If they're reconnected to the nerve, within a few weeks, they'll be able to grow back completely and begin contracting or moving again. But this ability to self-repair is time limited. If a muscle is disconnected from its nerve for over about 6 months, it dies, turns into scar tissue and fat. So while our surgeons can repair broken bones, lacerated skin, severed vessels, simply sewing back together a nerve that's been cut does not solve the problem. Why? If you cut a nerve to a muscle, the nerve downstream begins to degrade and it dies. Now, the nerves can regenerate or grow from the upstream stump, but they do so very slowly, at only about an inch per month. So if they have a short distance to transit, they can actually save their muscle. For example, if you cut a nerve in your wrist, within a couple of months, it'll grow down to the hand muscles when the damage is still reversible. But if you cut nerves in your shoulders, by the time those nerves get to the hand muscles, up to 2 years later, the damage is irreversible. The muscle is dead. You have scar tissue, you have fat, it cannot contract, it can't move. And basically what you have is a non-functional hand. You now have permanent physical disability. And these injuries are costly. Over about a year in Ontario alone, we will spend $28 million on the direct medical costs for limb trauma. And because these injuries impact people at the prime of their lives, you have massive opportunity costs like lost productivity that are also added in. So to solve this problem, researchers for years have been trying to make nerves grow faster, but with limited success. We have conducted drug testing in preclinical models, but many of these have had unacceptable side effects. Direct therapy by injecting genes into muscles have potential, but it's not practical. Muscle injections are painful, and you are significantly limited by the volume and the size of the muscles that you can actually inject. There are 34 muscles that control the movement of a hand. We can't inject them all. So our approach is completely different. We are going to treat the muscle directly, keeping it well and healthy until the nerve regrows. And we're going to do this by delivering gene therapy through a novel, targeted, and painless delivery method. The genes that we're going to use, or that we pick, are going to reprogram the muscle to keep it healthy until the nerve reconnects.
So here we propose to apply the novel approach of using ultrasound to deliver genes to repair muscle while the nerve regrows. With ultrasound gene delivery, the genes we want to administer are attached to microscopic bubbles. The gene microbubble complexes are then injected into the bloodstream where they circulate throughout the body. The mixture remains in the blood until we apply high-power ultrasound to the muscle we're trying to save. The microbubbles will pop, releasing the genes into the surrounding muscle. We'll first start by using ultrasound gene delivery in preclinical models to perform localized gene therapy for muscles waiting regrowth of that nerve. The beauty of this project is that microbubbles and high-power ultrasound are already in clinical use. In year 1, we'll identify the best genes to repair the muscle, and in year 2, we'll optimize timing and dosing of our genes. Finally, we'll get regulatory approval for human trials, and thus makes this a project of both rapid and highly translatable potential.
Accidental nerve injury causes permanent physical disability. Our solution has the potential to mitigate the physical sequelae of limb trauma, bringing people back to full functionality and a healthy, happy future. Thank you for your attention.
So what I love about this is you're proposing a treatment that in theory would be temporary. It's not something people would have to take forever. So in that sense, it could be somewhat of a cure, which is awesome. People don't want to be on meds their whole life. Can you tell me more about how similar technology has been used in people? You said ultrasound and the bubbles have been used in the clinic already.
Yeah, so I guess I'll take that question. So we use very similar microscopic bubbles in imaging every day in patients in our hospitals. I'm an echocardiographer, I'm a cardiologist, and so we use this in our echo lab to enhance the images that we see and create better diagnostic information. So with slight manipulations of these microbubbles, we can actually use them to carry genes.
Awesome, thank you so much.
What are the potential side effects with this delivery technique?
Well, the beauty of this and what we're proposing is these are temporary. This is temporary expression. So these aren't viruses. We're not introducing a virus, which is a bad word these days, but anyway, we're not going to introduce a virus that has permanent integration. We're using a tool called a plasmid, and they're just temporarily expressed. So we will be able to change what the muscle needs as time moves on. So it's temporary. There's nothing that's going to be left behind.
Thank you. It's amazing what a big impact tiny bubbles can make. Our next presentation comes from Dr. Monica Farkas, who wants to prevent kidney stones from returning for good.
Hi, I'm Monica Farkas. I'm one of the surgeons at St. Michael's Hospital. I'm also a researcher and an engineer. I think the first role models to me are certainly my parents. They are the hardest working people that I've ever met. They've also been very hands-on people throughout their life, and that's where I think I get my draw towards surgery, towards engineering. We were part of a household where something was broken, you looked it up and you fixed it. I was trained as an engineer before becoming a surgeon. During my training as a surgeon, I saw so many things that were being done just historically in a certain way, but there were better ways of addressing it. I'm very, very proud of being a female surgeon, specifically within my specialty, urology. 1 in 10 people in Canada suffer from kidney stones, and one of the most common ways we treat kidney stones is with laser surgery. When patients come out of laser surgery, 40% of them still have some residual stones, and that leads to a lot of follow-up, that leads to a lot of anxiety when they travel. It's very common for kidney stone patients to come to the emergency room 10, 20, 30, 50 times in their lifetime with a kidney stone attack. So we've come up with an innovative device that we can use during surgery currently to essentially aspirate and suck out all the fragments that are created at the time of surgery so that in the postoperative period, patients are stone-free and don't require further monitoring. At the end of the day, I like to unwind by spending time with my kids. I like to cycle, so we do a lot of cycling around our neighborhood. We've done long-distance cycling before as a team. I have so many roles on a daily basis. I'm not just a surgeon and an engineer. I'm a mother, I'm a wife, I'm an entrepreneur, I'm a researcher, I'm a mentor, and I'm still a learner. My team is very, very excited, and so am I, and can help hundreds of millions of people in the world.
Dr. Farkas, the stage is yours.
What I'm holding in my hand is 5 millimeters in size, but this is going to cause you the worst pain that you've ever felt in your entire life. Suddenly, you're going to drop to your knees and often violently vomit because of the pain, and you're going to think that you're dying. And what this is a kidney stone. And what you're feeling, the pain that you're feeling is from this very jagged stone as it scrapes its way down from your kidney to your bladder. And what I want to tell you today is that in just 3 minutes, we can eliminate these episodes of pain by using a device that we have created here at St. Michael's Hospital. Kidney stones are not just painful, they are life-altering. When you have kidney stones, you live your life in fear of an impending kidney stone attack, and that's because they're unpredictable. You can have a kidney stone attack very suddenly as you are walking your daughter down the aisle at her wedding. Kidney stones are recurrent. It's not unusual for someone to present to the emergency room 20, 50, or even 100 times in their lifetime. And kidney stones happen to people of all ages. You can be young, you can be old, you can be healthy, or you can be ill when you're having a kidney stone attack. Simone Biles, an Olympic champion, presented with the kidney stone attack to the emergency room just 2 hours before the World Championships. Kidney stones affect 1 in 10 people, and more than half of them will require multiple interventions to address their stones. And this leads to over $1 billion of spending yearly in North America. The most common treatment is laser surgery. And during the surgery, we pass a small camera from the bladder all the way up into the kidney, and we use the laser to break up the stone into small fragments. But here's the problem. These fragments are not always cleared. They often collect at the bottom of the kidney because of gravity, and over time they grow into larger stones, which form new kidney stone attacks. What I'm frustrated about as a surgeon, that when I see my patient in follow-up after I've just done surgery, is that 40% of the time I need to tell them that you've had surgery, but unfortunately you're not stone-free. There are still some fragments of stone left in your kidney. And we need to follow these. We need to follow them similarly to how we followed you before your surgery for your larger stones. And the reason for that is because they can grow, they can cause infection. And every time I see you in follow-up, I need to image the stones, and that's going to expose you repeatedly to radiation. And ultimately, even though you've had surgery, your stress and anxiety still hasn't gone away. And this is frustrating to me, and it's frustrating to my patients, and has led me to create a device that can finish the job and can suck out these fragments from the kidney. This device can be navigated anywhere in the kidney where the stones are and can eliminate these residual fragments during the time of surgery. Easy, right? Well, actually not quite. The engineering challenges that we had to overcome in order to create this device are astounding. And the reason is that we are working with very small instruments. The tube that connects your kidney to your bladder is only 5 millimeters in diameter, and our device has to navigate this tube. And so just to put things into perspective, the size of our device is essentially the head of the beaver on a Canadian nickel. So how are we able to do this? Well, the strength is in our team. Our team is a collaboration, a very close marriage between engineers and surgeons and entrepreneurs. I myself, as the leader of the team, I'm not only a surgeon, I am also an engineer. So there's immediate feedback for us for our device design. And as opposed to other teams that might have to meet on a weekly or a few weekly basis between their engineering team and their medicine team. So why should you invest? Well, you'll be investing in bringing forth a device that's really going to revolutionize the way we do kidney stone surgery. And this is very timely. And it's a device that's easy to implement. It only adds 3 minutes to the current surgical procedure. And it has a vast market potential. There is almost $2.5 billion in spending globally on kidney stone disease on an annual basis. So what is the impact of your investment? Well, we hope that with your help, we'll be able to optimize our design and validate our prototype further. And then hopefully within the next 18 months, start the approval process for human trials. But ultimately, what we hope is that our research efforts, combined with your financial support, will help patients and people to focus on the most important moments in their life without worrying about an impending kidney stone attack.
So curious, it seems like an odd question because this is the field you work in, but how did you come up with this technology, and is there other similar technologies somewhere else in the world? And you would think someone might have come up with this already.
And so actually what's happening currently, it's very timely in surgical treatment for stones, is that we are treating more and more stones with lasers because there's a brand new laser that has come out in the past few years that is very efficient at treating stones. And what this has resulted in is that we're treating larger and larger stones with laser therapy. And so we're leaving more and more fragments behind in the kidney. And these fragments are not passing. So there's actually a palpable buzz within the urology field currently for a device that's going to do that, that's going to suck out these fragments out of the kidney. And there's currently no device like this in the market. So we have a functional device that's doing this, so it's very timely for us to bring it forward.
My question is, what would the next steps be? Because this is a surgical device, it doesn't have as much, I'm guessing, of the regulatory steps. So is it just like testing it in some set of patients and then, because I want this available before I need it.
Yes, certainly. So where we are right now is that we have a functional prototype, so it does all the things that we want it to do. And we've been doing some preliminary testing in it, so we're going to continue our laboratory testing. So that's the very first step. Mm-hmm. There's still quite a few steps until we get to human trials. So, but it does have to go through a regulatory approval for human trials. The good thing about it is the way the device works is we're drawing upon some of the existing technologies.
For just 3 extra minutes, sounds like a good deal.
Thank you, Dr. Farkas. What a great solution to a painful problem. Now, our final team in this category want to fight brain fog from long COVID. Dr. Venkat Bhatt and Dr. Kareem Ladha.
My name is Kareem Ladha. I'm one of the anesthesiologists and clinician scientists at St. Mike's.
I'm Venkat Bhatt. I'm a psychiatrist and director of the interventional psychiatry program at St. Michael's Hospital. So there are 2 things which I liked growing up. One was stories, and the other was trying to understand how the brain does it. I had difficulty choosing between neurology and psychiatry, but it was really the storyline which made me decide to move towards psychiatry.
If you talk to my wife, she says I went into anesthesia because I don't like to talk to people. And traditionally, anesthesiologists do want to keep their patients asleep. So working with patients who have depression, it's a whole new world for an anesthesiologist to be in. In Canada, we are the only hospital program where anesthesia and psychiatry work together to deliver these novel treatments. And so for us, what we want to do is try and find new drugs to treat chronic pain and depression. So one of the things that we particularly want to look at is long COVID related to neurologic diseases such as depression, brain fog, fatigue. What we found is that there's a particular receptor that's implicated in this called glutamate. Now, as an anesthesiologist, that's a receptor we target all the time with a particular drug called ketamine. And what we found is that at lower doses, it actually affects people like with their pain and their depression in ways that we never thought it would.
So if I wasn't a doctor, I would be writing stories. I would be a novelist.
If I wasn't a doctor, I think I'd open a restaurant, Kareem's Taco and Barbecue Stop.
I would describe Kareem as collaborative and always having the patient's interests at heart.
Mine's not going to be as nice, though, I think. My one word for Venkat is stubborn, but I mean that in a positive way because he never gives up.
If we show that ketamine has efficacy in neuro-COVID, it can be scaled up and could be deployed right away worldwide.
Please welcome Dr. Bhatt and Dr. Ladha.
3 years into this pandemic, the last thing that anybody wants to talk about is COVID-19. But unfortunately for some people, that's simply not an option. I want to tell you a story about Sarah. Sarah is a nurse who used to work in the ICU. She was a marathon runner and could easily do a 10-kilometer run before a 12-hour shift. Unfortunately, during the first wave, she was infected with COVID. And to this day, she's unable to work due to persistent depression, anxiety, and fatigue. In fact, she can barely get out of bed. Unfortunately, Sarah's story is not unique. It's estimated that 10 million Canadians are infected with or have been infected with COVID-19, a number that only keeps growing. Approximately 1 million will have symptoms that persist, also known as long COVID, and 400,000 will have a disease entity that we're now calling neuro-COVID. A lot of people commonly refer to neuro-COVID as brain fog. It includes symptoms such as pain, discomfort, depression, anxiety, fatigue. And while we've all experienced symptoms like this at some point in our lives, for patients suffering from neuro-COVID, it can be completely debilitating and incapacitating. Unfortunately, at this time, there's no known treatment for this disease, and patients who have it are left suffering with little hope of getting better. But with your help, we hope to change that. Work from our group and others has identified a particular molecule in the brain known as glutamate. We believe that glutamate is responsible for many of the symptoms related to neuro-COVID. And as an anesthesiologist, we actually already have a drug that targets glutamate. It's called ketamine. And while we sometimes use ketamine in the operating room, we've also been able to use it in patients who are suffering from chronic pain and depression. In fact, it's actually a treatment that we offer at St. Mike's right now.
Working across departments, psychiatry and anesthesia, we have established a ketamine infusion program. We are the only available hospital-based clinical and research program with a mandate to look at repurposing anesthetic agents like ketamine for brain conditions like depression, pain, and now neuro-COVID. We will perform a cutting-edge clinical trial. We will recruit 40 participants with severe neuro-COVID, confirmed diagnosis of COVID with symptoms of neuro-COVID starting within 12 weeks after confirmation and lasting for 12 months, emphasizing severe neuro-COVID. These participants will receive 6 IV infusions, twice weekly of IV ketamine. And we will demonstrate at the end of the trial that with these infusions, it is safe, it is effective, and that it induces changes in the glutamatergic system, aligning with the effectiveness. We are ready to go. We have an established program with a large number of patients receiving ketamine for brain conditions like depression and pain. And we know that it works. We have access to patients with COVID at our COVID rehab clinic. We also have experts across disciplines, psychiatry, anesthesia, biomedical engineering, who have come together to be able to do the study. We are really ready to go. The impact of this clinical trial. This is the first trial worldwide with IV ketamine for neuro-COVID and to examine brain changes. We will develop a breakthrough treatment where none exists. IV ketamine is widely available, it's affordable worldwide, and can be scaled up. Importantly, ketamine is rapid acting, and you'll be able to notice efficacy within hours to days. In summary, neuro-COVID represents a massive burden of illness worldwide. With our interdisciplinary and innovative work, we are developing a breakthrough treatment for the 400,000 Canadians with neuro-COVID. And to go back to our nursing colleague, Sarah, who currently has no treatment options. We want to change that. Thank you very much.
Well, thank you so much. So I'm just curious about your next steps. Seems like you're ready to go. And if the trials show success, and regions in the regions in the brain that are affected show positive changes, then what does come next? Like, how do you plan to scale this locally? And more importantly, globally, because we know that this is a global problem.
One of the nice things about ketamine is that it's a drug that's already off patent. It's already available in hospitals throughout the world. It's actually on the World Health Organization's list of essential medications. And so unlike a new drug that we have to develop de novo with billions of dollars and takes years, this is a problem facing society now. And so by being able to repurpose a drug, we kind of bypass this. And so should this trial demonstrate efficacy, it's something that can be ramped up rapidly, not just at St. Mike's, but truly around the world.
My question is sort of two-parter. Is this an ongoing, you keep taking the ketamine, or is it you take it once and your long COVID has gone away? I'm assuming that's not quite how it works, but. And then the second part would be, are there any side effects from ketamine, and does it have some ramifications for people in any way?
Right. So question number one, we're looking at the acute phase. By that I mean 6 infusions with rapid efficacy.
Okay.
So people start noticing efficacy sooner, and then by 6 weeks, with 6 infusions, you get most of the efficacy. Based on our previous work, we think it will work for this condition. There's a neurobiological basis to it, why it should work. If glutamate is the most widely distributed transmitter in the brain, it should work.
Thank you. Very helpful.
One thing I've seen about long COVID is that the symptomology is all over the place. There's not one, grouping of symptoms. So could you tell us briefly, how will you assess that it's working when it can manifest in so many different ways in so many people? Because that's one of the hard things about studying it.
Right. So I emphasized earlier that we would be choosing people with severe neuro-COVID with validated criteria. So people would have diagnosed COVID-19 infection with onset of the severe neuro-COVID symptoms, depression, brain fog, and all the other things within 12 weeks after having had the COVID-19 infection, and the symptoms are persistent and pervasive for at least 2 months.
Okay.
So we are really trying to find the subtype which is severe, which has less heterogeneity. So, and we're doing brain imaging to actually parse out who responds and who does not. So that will allow us to actually see, for people who do not respond, what else could we do? Could we change the dose? Could we deliver it in a different manner?
We've just seen 3 very different pitches. Only one team can take home the $150,000 Keenan Award for medical discovery. Remember, you can vote for your favorite team from the 6 you see tonight for the Canada Life People's Choice Award at the end of the show. Voting opens at 8 p.m. Just visit angelsden.ca and click the vote link. Now, our panel of judges and jurors also have a big decision to make. Let's check in on the deliberations. Judges, how are you feeling? We've learned a lot.
I'm impressed, inspired. This is a very hard choice. You want everybody to take home $150,000 or more, because all of these are incredibly breakthrough and hit people in so many ways that are so important.
Eugenia, what did you make of the first 3 pitches?
I think I'm just so excited that this is happening, that this research is happening and this important work is going on.
This is the worst part about being a judge. I love being a judge, but having to pick is the worst. We need to just fund all of them. Yes. They are all solving problems for which we have no other solutions, and that's incredible.
I would also like to take this opportunity to thank all of our donors and sponsors. Our top prize award sponsors, the Patrick and Barbara Keenan Foundation and the P&L Odette Charitable Foundation. Our People's Choice Award sponsor, Canada Life. Our juror filming experience sponsor, Scotiabank and MD Financial Management. Our registration sponsor, Woodburn. Our reception sponsor, Plus Company and Camp Jefferson, and our team award sponsors, John Hunkin and Susan Crocker, Kensington Capital Partners, Deer Creek Golf and Banquet, and the My Hall Family Foundation. Of course, Angels Den could not be possible without the hard work and support from our Angels Den fundraising team. Finally, we have to thank our jurors. Their decisions, plus the votes from our judges, will determine who wins our 2 top prizes. Up next is the Odette Award for Health System Innovation. These 3 teams are pitching projects which use technology, data, and artificial intelligence to change how we deliver healthcare. Our first team is using artificial intelligence to customize how ventilators work for each individual patient. Have a look.
My name is Laurent Brochard. I'm a doctor in the ICU at St. Michael's Hospital, and I'm also a scientist, researcher in the Keenan Research Center.
My name is Mohammed Mamdani. I'm Vice President of Data Science and Advanced Analytics at St. Michael's Hospital, and I'm also a scientist at the Lee Cushing Knowledge Institute. Well, when I was a little kid, I wanted to be, I think it evolved from wanting to be a police officer because you get to boss people around, to a garbage collector who gets free things, to I have no idea what I want to do, but I want to do something that's fun, exciting, and makes a difference to people.
You know, as a child, I think I wanted to make things right, to help people.
One word for Laurent is really difficult, but if I had to pick one word, it would be visionary. I think Laurent has this unique ability to not only be able to look at specific pieces of a problem, but their entirety. That's transformative.
Mohammed is a fantastic person, but also as a leader. He has a vision, and people in his team are sharing the vision. During the pandemic, there were many patients put under a ventilator, but every patient is different.
There's a mortality of roughly 30%, so almost a third of patients die when they're on mechanical ventilation.
What we want to do is to individualize the experience with mechanical ventilation in every ICU bed in the hospital.
Can you use data and artificial intelligence to actually alter these parameters in real time to really impact the breathing of these patients so they actually have a better chance of living and surviving? Something that I do to relax, which my teenage daughter cringes at, is I like playing video games.
I like painting.
You're a painter? I didn't even know you were a painter.
We think maybe this pandemic is over, but the next one will come. We need to be prepared. So we are really working for the future.
Here to demonstrate the future of the ventilator, two world experts, Dr. Laurent Brochard and Dr. Mohammed Mamdani.
So we all breathe, and our brains and lungs do that naturally, and it's a beautiful process. But what about if you can't breathe? I'm going to ask you for a few seconds a simple experiment. Just stop breathing. Stop now. Okay, I don't want any accident tonight. Thank you. It's just to make you feel, well, first how irrepressible it is to breathe, but also to think about how painful it can be when you can't breathe. And there may be many reasons for that. It could be you have bad lungs because of the flu or COVID, but it's also the heart is not working or the brain is not working. And these are many reasons to come to the ICU and to be put on a ventilator, a machine which will help you breathing. So in terms of numbers, it's huge. Before the pandemic, we think 65 to 90,000 Canadians a year needed a ventilator for these reasons. That would be like 20 million in the world. During the pandemic, this was multiplied by 4 or 6. So ventilators save life, but still 30 to 40% of patients die on the ventilator. We know that improper ventilation settings will harm the lungs and the whole body. And each day on the ventilator will prolong the recovery. And there are many long-term complications like weakness, fatigue, memory loss. So we think we should and we can do better. So why is it so complicated? Because every patient is different. And what the ventilator gives must match what the patient needs. The patient still breathes. So what we hope the ventilator will do, ideally, is to work in perfect synchrony with the patient. But this is what's difficult to achieve. If you think the ventilator monitors the patients and sends data every 20 milliseconds, but clinicians can check, only 2 to 4 hours. We have been working on that for years. So this may look very messy, but this tells us how the brain and the lungs of the patient interact with the ventilator. And from these data, there is life, and we can immediately see what's happening, where it's good or bad. So we think we have the solution. We are the best team in the world for that, but we need to work with the best AI team in the world. So that's where we go together.
Thank you, Laurent. The average patient will breathe in for about 2 seconds and breathe out 2 seconds. So if you think about the 2 to 4 hours, that's thousands of breaths that patient will take. That's hundreds of thousands of data points that will be generated by the ventilator that our clinicians will not see. And all it takes is one breath, one misstep, and the consequences? Well, the consequences can be fatal. What if we had something that was monitoring our patient every millisecond, continuously monitoring our patients, and would be able to tell us, I think there's going to be a problem, and would be able to alert our clinicians so they can actually see the patient quickly and effectively to save that life. This is why we're excited about artificial intelligence, because this is what it enables. It enables that continuous monitoring, and we believe AI is the solution. What we're proposing is a world first. There's nothing like this in the world. We're proposing the Center for Artificial Intelligence and Ventilation. We'll be the first, and what we will drive towards is personalized ventilation for the ultimate goal of saving lives. We're in a really lucky spot. St. Michael's Hospital has the #1 critical care physician in this space, in Laurent. Our AI team, our applied AI team, has been recognized as a world leader in our space. And the collaboration here is just natural, and I think will really be impactful. But what do we need? There's a lot of specialized equipment that goes into actually making this a reality in actual practice, and specialized people who focus on waveform data analytics. And that's what we'd use the funding towards. We are actually along in our process. We believe we can actually, with this equipment, personnel, and your support, be able to generate a prototype within 6 to 12 months to be able to start testing in clinical practice. And we're very optimistic because we've already seen publications that may be effective here. And we've actually done some of that work ourselves. So it's very exciting. This will revolutionize the ICU. We're anticipating at least increasing survival by at least 10%, reducing length of stay by at least 40%, and increasing the quality of life of our patients by at least 30%. All of this will be transformative and allow us to just breathe. Thank you.
Thank you so much. What I can't believe is that it's a world first, because everyone's jumping on the AI train. So how are there not other people, other companies, China, Silicon Valley not already throwing money at this?
The project here is to do that at the level of the hospital, where we have many brands of ventilators. And I know the companies working, they don't have the clinical expertise.
So it's you.
And yeah, right. So I prefer St. Mike's. So, and they don't, we want a solution for any ventilators. And also we want to connect with monitors, looking at the heart and any signals from the patients. So we want a global solution, and nobody is doing that.
Thank you.
How would you be able to deploy this in other hospitals, even globally, if you've thought that far?
This is an excellent question. This is something that a lot of people struggle with is, you can get it done here, how about all the other places in the world? I'm going to mention in April, we launched a startup called Signal One for that very purpose of how we actually deploy these solutions outside. Initially, we'd kind of approached this saying, we're going to be open source, we're going to give our code away and people will be able to, it doesn't work. It really doesn't, because the amount of expertise and technical skill set you need is beyond what most hospitals have. So the chief AI officer of TD Bank actually stepped down to actually have this startup and form a partnership with Unity Health for that very purpose of bringing that technology and deploying other places.
Thank you, Dr. Mamdani and Dr. Brochard. It's comforting to know if we ever have to be in the ICU, these world experts are working on better treatments. Our next team believes analyzing current patient records can help prevent another pandemic.
My name is Stephanie Garys. I'm a postdoctoral fellow working with the family health team at St. Mike's Hospital. My name's Andrew Pinto. I'm a public health specialist and family physician at St. Michael's Hospital and one of our clinician scientists, and I direct a research team called the Upstream Lab. My mom is a pediatrician, and so I always knew I was kind of drawn to medicine. And along the way, I realized I really loved research, and that research could be a tool to create change.
I think early on I had first wanted to be a veterinarian and then later a doctor, and then eventually research just felt like a really good fit for me. I had known about Andrew's work for a while, looking at issues related to social determinants of health and also using big data sets. And so I decided to reach out and see if he'd be interested in supervising me for a postdoc.
What we're doing now is using all of the health record data that emerges from people going to their family doctor and using that to detect early when a respiratory pandemic is going to happen. So with this Angel's Den funding, it allows us to actually build and test different models that use artificial intelligence to process data from millions of people.
Andrew and I have been working with data from primary care electronic medical records for a very long time, so we know the data really well.
We're generating all this amazing data and using it to be more proactive and actually anticipate issues before they become real threats. If I was not a physician and scientist, I would actually be a carpenter or a woodworker. I just love that.
In an alternate reality, if I had unlimited talent, I would probably be a professional soccer player.
What we really need is a system that can see the whole population. So it could allow communities to get back to normal work, normal school more quickly than what we experienced during the COVID pandemic.
Please welcome Dr. Andrew Pinto and Dr. Stephanie Garies.
So I want to take us all back to New Year's 2019. It was, the celebrations were happening, a new year was coming out, and we really didn't know what was going to hit us. We had no way of knowing that the largest pandemic in the last century was going to be upon us and change all of our lives. 17 million people dead, changes to every aspect of our life. Now, what if I could tell you that although we made fantastic progress in science around vaccines, things like rapid tests, that from a public health intelligence perspective, we weren't using the data that we had available. And as the Auditor General put it, this was a massive intelligence failure. We actually were not using this full set of information we have at a population level to be able to predict and understand what was coming. Now, most people, when they have a cough or the flu or COVID, they develop cough or fever or chills, and they present to their family physician or the emergency department, and that gets recorded. And that's actually the harbinger of a pandemic, but we can't see it right now. No human can take in all of this data from millions of people and be able to see that there's something amiss. This is actually the system we have right now, fax machines. This is how myself as a family physician, I would let public health know there's something strange going on. So obviously we need a better solution.
So introducing Outbreak Alert. We're building an AI-based early warning system for the next pandemic. So imagine you go to see your family doctor because you're feeling unwell. Your family doctor enters information about your symptoms into your electronic medical record, things like fever, cough, body aches. Our Outbreak Alert system will use this health data to apply an advanced search using a type of AI called machine learning. Machine learning gathers vast amounts of data to look for patterns that are associated with a case of respiratory illness or not. This type of tool can run continuously in the background without interrupting patient care or being a burden for doctors. Then we can take a number of patients identified with a respiratory illness and send that information to public health organizations so that they can monitor trends in specific geographic regions and, most importantly, act early. So if we were successful at Angel's Den, we're actually ready to get started right away.
We have access to a unique clinical data set with over 11,000 family doctor visits. After we hire a data scientist and a project coordinator, we can start to build and train and test the machine learning models. Then we can share this information with public health organizations who will co-design this work with us and implement a secure transfer of the anonymous information. This work actually sets us up really well to be able to detect lots of different types of respiratory illnesses in the future. And we can even start to spread and scale this alert system across the country. So we have a fantastic team in place. It's multidisciplinary. We have experts in medicine, in artificial intelligence. We're also collaborating with provincial and national public health organizations. And they're really excited about this work because they see the huge value of using family medicine data in such an important and innovative way. And with the potential to scale nationally, this outbreak alert system is something that could benefit all Canadians and could even bring international recognition.
So we know that the next pandemic will happen, and it will be where somebody presents to primary care a system that touches everybody in a population, and that we need to be prepared. We need to solve this intelligence gap. And remember, this is something that no human can do right now. We actually need this technology to be able to do it. And the really exciting thing is it could help us identify patterns for future outbreaks of things we're not even expecting, things like monkeypox or other infectious agents that actually just come out of nowhere and help us be prepared for that. So we look forward to getting started with this project and all of your support.
Honestly, the whole time you were presenting, it was just in the back of my mind, why hasn't anyone done this before? What is going on here? Especially because we just came out of a global pandemic and no one thought of this. So why hasn't anyone done this before?
I think the pandemic has accelerated people's thinking about this, whether it's people at the Ministry of Health, Public Health Agency, or other partners that we have. So everybody is really excited about this, the potential for this. It'll replace these kind of archaic systems that we have right now, and things like sentinel surveillance, which have really seen dwindling kind of engagement as people are getting overworked and really tired. So that's, I think, why nobody's done this before.
I will also just jump in and add, a big part is we need electronic medical records to be able to gather all of this data so that machine learning models can train and test on them. I think there are some hospitals that might still use paper charts. So it's really difficult. Well, it's impossible to run AI on paper charts. So, you know, there was a big shift in clinicians getting onto electronic systems as well.
My question relates to public health. So they'll get this great information. I wonder what they'll do with it. Like, what do you think will happen with it?
So I'll take this one. Part of my training is in public health, and so I see all of my colleagues as medical officers kind of taking this information and actually using it for targeted interventions. So this would actually help us see where in the province are we seeing early signs of
targeted
outbreaks.
Lockdowns, maybe.
Yeah, potentially targeted public health measures. I tend to think of it in a more positive way, more like more supports, better testing, faster vaccine delivery. You know, focus in on that those areas. So that's one kind of key use of this. I think another area will be actually expanding the need for public health and actually saying we need to be investing more in these public health systems because there's this growing need and this threat.
I am learning so much tonight. Please continue your work and protect us from another pandemic. Thank you, Dr. Pinto and Dr. Garys. Our final team wants to expand their app to ease the debilitating impact of endometriosis.
Hi, I'm Elizabeth Miazga. I'm a clinical fellow in minimally invasive gynecologic surgery here at St. Michael's Hospital.
My name is Dr. Carmen McCaffrey, and I'm an obstetrician and minimally invasive gynecologic surgeon specializing in endometriosis here at St. Michael's Hospital.
So our relationship goes way back. When I was a medical student at U of T, I got assigned to a random resident mentor who happened to be Carmen McCaffrey. This was 10 years ago. She's kind of mentored me along my whole sort of journey through medicine. So endometriosis is a condition where the lining of the uterus, or cells similar to that, called the endometrium, implant somewhere outside the uterus. We hear about girls or women who can't participate in school and who miss their classes or drop out of high school or don't go to university because their period pain is so bad that they have 5 days a month where they're on the couch and can't move.
So endometriosis can cause infertility. It can be one of the most devastating consequences of this disease.
Our goal is to really provide them care so we can improve their quality of life and help these women and people assigned female at birth achieve what they want to achieve.
Their wait time to see an endometriosis specialist can sometimes be upwards of 1 to 2 years. And again, they wait for surgery for 1 to 2 more years. Unfortunately, a lot of these first-line treatments that we recommend for all patients are expensive, or they're just inaccessible for patients that don't live in a major center. That's where the idea of the MyEndo app came.
It's a one-stop shop for people with endometriosis to get all of the care that they need for their condition without cost to them. So I think my friends and colleagues would describe me as a ball of energy.
If you're stuck in the OR with us, we'll, get more excited and talk faster and faster and faster until the residents will be looking at us like, what is going on? My kids would probably say, I'm pretty fun, kind of silly, full of energy, can shoot a pretty good free throw, while also running around in the backyard with a soccer ball.
So if I weren't a doctor, I would probably be a lawyer. So I come from a family, like both my parents and my older brother are all lawyers. I think lawyers are great advocates. In medicine, I've really tried to find ways I can bring that advocacy into my practice here. Together, we're really passionate about advocating for this disease to better advocate for our patients.
Here to provide endometriosis treatment at your fingertips, please welcome Dr. Carmen McCaffrey and Dr. Elizabeth Miazga.
Endometriosis. Do you know what this disease is? Many don't, which is shocking considering millions of Canadians suffer from this debilitating condition. Imagine barbed wire wrapped around your internal organs. Or imagine this, your 14-year-old daughter cannot go to school because of debilitating pain. Imagine at 27, you can't have a baby because of infertility. Imagine pelvic pain that brings you to your knees because of internal bleeding. And it gets worse every month. This is endometriosis. Endometriosis is where tissue from the uterus attaches to other parts of the body. It can cause organs to fuse together into a solid block. It can be so severe that it can attach to the bowel, the lungs, and even the brain. We want you to hear from one of our patients how endometriosis has affected her.
It meant missing school and work on a regular basis because I was in so much pain I couldn't get out of bed. It meant spending thousands of dollars of my savings on IVF to preserve my fertility, thousands of dollars on chiropractic care, physiotherapy, acupuncture, osteopath treatments. And most recently, it meant this. At 33 years old, I needed to start walking with a cane.
1 in 10 women and an unknown number of trans and non-binary people have endometriosis. In Canada, we are spending $1.8 billion every year treating this disease, and patients are still not getting what they need. This astronomical amount can be attributed to delays in treatment and care. Patients are waiting 5 to 10 years or even more just for a diagnosis, and even longer after that for surgery. We need to do better. There are proven treatments for endometriosis that are available, but they are not covered by provincial health insurance plans, making them unaffordable and inaccessible. Our patients need help today, and luckily, we've got answers for you.
So the solution is the MyEndo app, which is the only app of its kind, and it's free. The app will guide patients through proven treatments to help them manage their pain. We hope to create all of these modules for patients so we can help our patients get back to school, get back to work, and for some, this may even prevent the need for surgery. For example, physiotherapy is recommended for all endometriosis patients, but a single session can cost between $100 to $200, and patients need recurring sessions. This is unaffordable for so many people. But with funding, we could eliminate this cost barrier and create accessible modules of physiotherapy for all of our patients. They'll be housed on the app.
So the first version of the MyEndo app is already built and it's ready to go. It has some really basic content on it. With $150,000, we'd be able to create all of these new modules and have them ready to go and researched within a year. This expanded app will also be able to gather data so we can do some really important and needed research in this population. We need to know more about patients with endometriosis so we can continuously improve the care that we provide. Angel's Den funding would completely cover all needed costs for our app and make it a reality. This will change millions of lives. We know that diseases that mainly affect women receive less research funding and less recognition. This leaves women to suffer for years. We need to address this disparity and to say that women's health matters.
So it's time to support better care for endometriosis. Maybe you are the 1 in 10, but if not, you certainly know someone.
Support us so when your daughter has severe pain at age 14, it doesn't prevent her from finishing high school.
Support us so that families don't have to choose between a $200 physiotherapy appointment and $200 worth of groceries.
Support us because women's health matters.
Thank you.
Why is it so difficult to isolate endometriosis? And probably more people have it than we even know, the 1 in 10, but maybe you could expand on that.
So there's a ton of different reasons why. First of all, a lot relates to healthcare disparities for women, which is why we talk about this. There's really good evidence to show that women's concerns, and particularly women's pain, is taken less seriously by their physicians. So a huge part of our app and what we want to do is really talk about this disease. That's why we're so excited to be here and talking to all of you about this so people know about it. So that's not normal that if you can't go to school because your pain is so bad, you should see a doctor because we have really good treatments that can help you out. And hopefully we're going to make some steps forward after this to make these treatments even more accessible to our patients and make the education and the diagnosis a lot easier for them to get access to as well.
So I want to ask, would there be any barriers to accessing this? Do I need to pay? Do I need, how will I know about it? How will I get it on my phone if I need it?
Yeah, so that's a great question. And really that's what drove this whole project for us. We got sick of sitting in clinic and seeing patients that we knew we had treatments for, we recommended treatments for, but then we found out they couldn't afford physiotherapy, or they didn't live in a major center that even had someone that specialized in endometriosis that could help them. And so the whole point of this is that it's barrier-free. It will be accessible to everybody. It will be free. We will never make anything off of it. It is entirely meant for our patients. And the great thing is we can continually add to it as well. We've set it up so, over time, even if we develop new treatments or new research comes out, we can, continually add to the app and make it better and better.
I'm curious about this project and kind of the working relationship that you both have. What really inspired an app of all things? I know, accessibility is a thing, but I'm just curious about that.
With patients with endometriosis, these are particularly young people. Our patients are, 14 to 50. So people are tech savvy or on their phones all the time, as we are too. And so it's something that we thought, and when we talked to patients in clinic, they said, that's a really great idea. That's something I could watch on the subway or do on my commute home or access at any time I really needed it. So if it's 3 a.m. and I have a pain crisis, the app is there, it's at my fingertips, and I can get the help that I need. And so it's really that, as we talked about before, that focus on accessibility and making sure this care can reach everyone who really needs it.
A free app that can provide care for such a crippling condition is so needed. Thank you, Dr. McCaffrey and Dr. Miazga. So we've now seen 6 captivating pitches. Each one has given us a view into the future of healthcare. The work coming out of St. Michael's Hospital is transformational, and it's been so inspiring to have these scientists share their brilliant solutions. Judges, You and the jury have quite a task ahead of you. So what is going through your minds right now?
We've seen innovations for more personalized medicine, ones looking at the big picture view at the population level. Clearly, they're all very necessary, so donate and fund all of them is all that I'm thinking.
Yeah. Eugenia?
I feel like I wish I were Oprah. Like, you get a grant, you get a grant. That's all I want to do right now, but I can't. So I really love that we are exposed to this, that the world is exposed to this, and that this can be an incredible platform for increased support beyond Angels Den. That's my hope, and that's what I get comfort in, because I want all of this.
All of it, right?
Yeah.
Right, Jillian? All of it.
Oh, yeah, I'm with you. We
You
want
get a
all
grant.
of this. There are amazing researchers in this hospital, and there are amazing things going on. You're right. It doesn't end here. It just gets started.
First to present the Keenan Award for Medical Discovery, co-chair of Angels Den, St. Michael's board member, and daughter of Patrick and Barbara Keenan. Please give a warm welcome to Gwen Harvey.
I'd like to congratulate all of tonight's researchers. On behalf of all of us here tonight, it's been such a privilege to learn along beside you through the work you've presented tonight, so thank you. Watching on stage, what was remarkable was that this group, you're all researchers and you're practicing physicians. And we could certainly feel that curiosity and commitment to your work, but also the compassion for your patients. So thank you for all you do. And so now, the Keenan Award for Medical Discovery goes to Dr. Monica Farkas.
Congratulations. Congratulations! You've just secured a huge $150,000 to help take your research to the next level. Now, here to present the Odette Award for Health System Innovation, he is a legendary philanthropist and one of St. Michael's most steadfast supporters. Please welcome Lou Odette.
Thank you, Rishmi. For 8 years, Angels Den has been rewarding the hard work of St. Michael's brilliant minds. Every year, I'm amazed that these scientists reach new heights and find new ways to make life better. I'm honored to present the Odette Award for Health System Innovation to, here's the envelope, and the winner is Doctors Mohammed Mandami and Laurent Bouchard. Congratulations. Yes. Tremendous.
Congratulations to our 2 winning teams and all of our finalists. Now it's your turn to be a part of medical history and have your voice heard. Go online or scan the QR code on your screen to vote for the Canada Life People's Choice Award, worth $100,000. Voting is open now for 1 hour at angelsden.ca. We'll announce the winner of the Canada Life People's Choice Award tomorrow morning on CP24 Breakfast and at angelsden.ca. If you want to go behind the scenes and fund groundbreaking projects, go to angelsden.ca and make a donation or join our Research Innovation Council. We are thrilled to announce that next year, scientists will have a chance to compete for one more top prize at Angels Den, this time to support cancer research, courtesy of the Sarah McComb Benefit Fund. From Angels Den, I'm Rashmi Nair. Remember to vote. I'm going to vote now. Have a great night.